Hi guys, welcome back to my channel. In this video, we are going to cover monostable multivibrator using Opamp. I have covered this same topic in Hindi, so if you want to watch in Hindi, I will provide the link in the description. So let's start. First, we will see the concept, why it's called one-shot multivibrator. Then we will see circuit diagram, working and waveforms. So concept is very simple. Mono means one, so it has one stable state. So to change its stable state, you have to give trigger pulse. Now this circuit has positive feedback. So when you give positive feedback to your circuit, there are only two possibilities of output, Vsat or minus Vsat. Okay. So what is stable state over here? Stable state is high, means Vsat. Okay. So the output of circuit is in stable state, means is in plus Vsat. And when you apply trigger pulse, I applied trigger pulse over here, then at this point it will change its state and it will go to minus Vsat. Okay, so this state is known as quasi stable state. This is temporary stable state. Okay, because it is going to jump from minus Vsat to plus Vsat again. For a particular time period, it will remain in this state and it will return to its original stable state, that is plus Vsat. So if you again apply trigger pulse, it will again go to minus Vsat for some time and then it will return to plus Vsat. Okay. So this is the core concept. Now we will see how this circuit is producing that waveform. So circuit is very simple. You are providing negative trigger pulse at V1, then there is R1, R2 network, then there is feedback resistor RF and one capacitor, one diode connected in parallel and connected to V2 node. Okay. So first of all, how does this circuit goes into the stable state, that is Vsat? Now initially there are no inputs. Initially neither this trigger pulse nor any input is applied to this circuit. Okay, when there is nothing at input side but there is some small voltage at output side, that leakage voltage is called output offset voltage, VOOT. Okay, so initially this small leakage voltage is present at output, and due to this positive feedback, what happens, this value gets amplified, and as this value is positive, your output jumps to plus Vsat, because output has only two options, plus Vsat and minus Vsat. So this value is positive, so it jumps to plus Vsat. So this is how your circuit gets into stable state. So initially it is in stable state, that is output equal to plus Vsat. So now you understood from where this Vsat has come. Now we will understand how does this circuit maintains this stable state. So first of all, this Vsat is appearing across the P terminal of the diode. So this diode is getting positive voltage at its P terminal, so it is forward biased. So this acts as a short circuit. Okay. So when the diode is short circuit, it has 0.7 volts across it, if it's of silicon. Okay. So same 0.7 volts come across this capacitor. Okay. So your V2 means this node is V2, right? Is nothing but capacitor voltage Vc, which is equal to voltage drop of that diode, that is 0.7, for example. Okay. Now what is V1? If you observe, V1 is nothing but voltage across this R1 resistor. So you can simply apply voltage division rule. Sum is R1 plus R2 and we have to find voltage across R1. So R1 is in numerator. Into total voltage is VO. Okay, VO is coming across here. So your V1 is R1 upon R1 plus R2 into VO. Now this term is nothing but beta. We will call it beta so that we can replace it with beta into VO. Okay. Now currently your VO is nothing but Vsat. So your V1 becomes beta Vsat. Okay. So we got values of V1 and V2. Now why do we want values of V1 and V2? Because we know the equation for output of Opamp, gain into difference, V1 minus V2. Okay. So here V1 is nothing but beta Vsat minus V2, which is 0.7. So obviously beta Vsat will be greater than 0.7. 0.7 is very small value. So this difference V1 minus V2, so this difference is positive and it is going to be amplified by this gain. Okay, so this is how the stable state is maintained. Because this diode is short circuit, there is 0.7 at V2, so V1 is always greater than V2. That's why your output is Vsat, always. till you apply the negative trigger pulse. And when you apply negative trigger pulse, you apply it at V1 node. So suddenly V1 becomes less than V2. Okay, because V2 is 0.7 means still positive, and V1 is now negative trigger pulse. So this difference is now negative. Okay, and then this negative value gets amplified and output jumps to minus Vsat. So to make output jump from plus Vsat to minus Vsat, we have to provide negative trigger pulse. Okay, now what happens after negative pulse is applied, that we will see, but first we will draw the graphs. So till now we analyzed the stable state. So there was no trigger pulse. Okay, and voltage at capacitor means voltage at V2 was 0.7. Okay, and output was stable means Vsat. Now we are going to apply trigger pulse. So now I applied negative trigger pulse. Now what happened, that difference turned negative and your output jumped from plus Vsat to minus Vsat, because now V1 is less than V2. Okay, so now your output is minus Vsat. Okay, now the same minus Vsat value is appearing across this P terminal, and now this diode gets reverse biased and acts as open circuit. So now this diode is open circuit. So this capacitor has got path to charge towards minus Vsat. Okay, so it is following this path and charging towards minus Vsat. So now your V2 means Vc approaching to minus Vsat. Okay, and what is your V1 over here? V1 is nothing but beta VO, and now VO is minus Vsat. So VO will be minus beta Vsat. Okay, so now both are negative. Now to make this difference positive again, okay, now it is negative, that's why it's minus Vsat. So to make this difference positive again, V1 should be greater than V2, means Vc should go below the V1 means minus beta Vsat, then this difference will turn positive again. Now I will explain you through graphs, then it will be clear. So Vc is charging towards minus Vsat, but it won't reach minus Vsat. Okay, so when it will try to cross this threshold is nothing but V1, right, minus beta Vsat. So suppose this is minus 5 and capacitor voltage is becoming more negative and negative, and it goes beyond minus 5 means minus 6. Now V1 is greater than V2 means capacitor voltage. Okay, because minus 5 is less negative than minus 6. So the difference turns positive again and the output jumps back to plus Vsat. Okay, and the cycle gets repeated. Again the diode will be short circuit. Voltage drop will be 0.7 volt. So it will come back to 0.7 volt again. So this is how it went to quasi stable state, then it came back to stable state again. Okay, now we will quickly summarize the working. So first it was in stable state when output was Vsat, V1 was beta Vsat and V2 was Vd because diode was short circuit. Then you applied negative trigger pulse, so V1 became less than V2 and the difference turned negative. So output jumped to minus Vsat. Now the value of V1 is minus beta Vsat and the capacitor is charging towards minus Vsat because diode is now open circuit. When Vc will try to cross minus beta Vsat, V2 will be less than V1 and this difference will turn positive again and your output will jump back to plus Vsat. Okay, so this is how the monostable multivibrator is working. It is very simple. If you pay attention and listen to this video, you will surely understand the working. Okay, so this was working of monostable multivibrator using Opamp. So in the next video, I will cover the derivation of frequency of oscillations for this circuit. I hope the working of monostable multivibrator is very clear now. If you have understood this video, press the like button, share this whole playlist with your friends and subscribe to my channel. Thank you.